Okay, so we have officially finished our transformations unit. So that's done. Yes, we are recording. Yes. We have officially finished our transportation unit, so we don't have to worry about rotations and translations and all that good stuff until STAR test comes around. Now, today we start our second to last unit. So we are getting close to being done with everything.
You can just wait, is useless now? No, I'm kidding.
Okay, so today we're getting into our unit over what's called data representation. This is how we have various ways of representing data and analyzing those sets of data so that we can get certain ideas about it. Today we're focused on scatterplots. The good thing is scatterplots are really not that hard. They are exactly what they sound like. They're going to be plots that are scattered on a graph. Now, we have spent a lot of time in this class talking about various types of relationships. Okay, whether it's a proportional relationship, a non-proportional relationship, a linear relationship, all these different forms of how X and Y work together, or how they're represented and how they interact with each other. Okay, and so we're going to continue that, but scatterplots take that idea and they put it in a more real-world environment. Okay, and what I mean by that is, in our math book, we might have a problem when we're talking about the hours that we drive and the miles that have been driven. And it might say something like, you're going 60 miles per hour, so after 1 hour you went this far. And after 2 hours you went this far, and 3 hours, and it makes this really pretty straight line, right? And it's so nice. Okay, so we get problems like that a lot. Okay, this is the number of hours, or this is the miles per hour you're driving, and so that's what it would look like on a graph. Okay, now, is that how life really works? No. Just because you're driving 60 miles per hour doesn't mean that after 1 mile, you're necessarily going to have gone 60 miles. Okay? There's other factors that come into play in real life. There's traffic. There's the need to stop and get gas and different things like that. And so, in real life, if we were to graph that situation, okay, so this will be real life. Let's say, again, it's miles in hours, but this is a true road trip. Okay? So, starting out, you're doing pretty good. Everything's going good. Now, you might have to stop at one point, or there's an accident, and so different things are going to affect that. Okay? And we're going to get something like this. Okay? It's not going to give us a pretty straight line, right? It's going to give us various points. Okay? Now, that's one person going on a trip. Let's say, rather than just looking at one person going on a trip, we talk to several people who are going on a trip, and we say, okay, well, after this much time, how far did you go? And how much, for you, how much time did you travel after that, and so on and so forth. It would start to look like a very random series of points, right? This would be data collected from several different sources. Okay, this is what real life would actually look like. Okay, and so it's going to give us, can we see that there's a relationship between hours and the miles driven?
No.
You can't tell that when, well, I'll go ahead and show you the relationship. You see, when hours goes up, miles tends to go up. See how they're all traveling in the same direction? So, yeah, there's a pretty clear relationship between miles and hours, okay, assuming we're driving at that speed, okay? So, just because it doesn't work out all pretty doesn't mean that there's not a relationship, okay? Most things in our life are not pretty like this, okay? In fact, the only times that we really have linear relationships in the real world is when we're converting between like feet and inches, or something that's going to always go up at a constant rate. With things like this, all right, there are other variables at play. So, the most important thing with scatter plots is being able to identify various relationships. Okay? There are 3 types of relationships in scatter plots. Okay? We'll talk about the first one here. The first one is like what we just looked at. Let's say we're talking about the relationship between your grades.
Oh, yeah, it's gonna go down. Yeah.
And your time studying.
Oh, yeah, it's gonna be like negative. Yeah, definitely.
All right, so obviously, as you study less, what's probably going to happen to your grade?
You're gonna go up. Yeah, get to negatives.
All right, jokes aside, as you are studying less, what happens to your grade? Typically goes down. Okay, what if you study a whole bunch? Might be up. Okay, now there's going to be people all in between studying various amounts of time, right? All right, now, on top of that, there are the few out there that study none at all and still make really high grades, right?
Yeah.
There are other people who study a ton and then still fail the test, right? So, we can see here that we have a relationship for the most part. Okay? Now, these little pieces that are sitting out here, those are called outliers. Okay? And most relationships have them, outliers. They lie outside of the norm. Okay? They're not part of what you would say is the normal relationship.
Did we learn this last year?
You should have, yes. So, outliers are normally, they're pretty easy to spot because you'll see all the other points are kind of moving together and then there's a random point that's off to the side. That's going to happen. Okay? If we were to all go to the swimming pool and try to time our laps, okay, with our skill level, we would all be about, there'd be a little bit of a range, all right, based on skill level and your time. And then you'd have random freaks like Michael Phelps who'd go out there and just blow everyone out of the water, right? And so Michael Phelps is going to be your outlier in that situation. He does not represent the normal person in a swimming pool, okay? So, you're going to have outliers when you have real-world information, okay? Now, but for the most part, when we're talking about grades and studying time, we can see that when your grades go up, your study time typically goes up. Or when your study time goes up, your grades go up. And when your study time goes down, your grades go down. And so both variables are moving in the same direction. When one goes up, the other goes up. When one goes down, the other goes down. Okay, so if they're moving in the same direction, that is called a positive, did I spell that right? Yeah. Positive association. Okay, that's what we're discussing here is associations. I may be spelling everything wrong. I don't know. Associations, okay? Positive association, you may hear me use the word correlation. Means the same thing, okay? It's the same thing. Correlation, association, 2 words for the same idea, okay? Sometimes I'll just say relationship, okay? With a positive association, both your variables move at the same time. So let's look at the next one. What do you think the next one's going to be called? Let's think critically here. Negative. Hey, there we go. Negative association. Okay, now, with a negative association, when we had positive, we moved in the same direction, right?
So we're going like...
Now we're going to move in different directions. Okay? The example I used last class period, how many of y'all are familiar with golf at all?
I hate it.
I didn't ask if you liked it, are familiar with it. Okay, what about putt-putt? Okay, more people in putt-putt. Okay, that's fine. In putt-putt, the way you do your scoring is the lowest score wins, right? So if me and Cal are playing putt-putt, and she gets, she gets the ball in after 3 putts, and it takes me 5, and she wins, because 3 is better than 5, right? And so after 18 holes, you add together your scores, and whoever has the lowest score wins. Okay? So, in a game like basketball, the higher your skill level, the higher your score, right? But in golf or putt-putt, the higher your skill level, the lower your score, right? So, if we said golf score was one of your variables, all right, and your skill level was the other, okay, those who had a really low skill level would have a very high golf score, right? And those who had a really high skill level would have a very low golf score. And then obviously if we took a bunch of points in between, it'd be like that. Okay, now obviously there's going to be somebody who just gets lucky a bunch. All right, or you have your Tiger Woods of the world that are just, all right, who maybe has a bad day. All right, so skill levels are really high, but they scored bad on that day. Maybe it was raining. Okay, and right here they just got lucky. Those are our outliers, right? But we can see that for the majority, we do have a relationship that is heading down. So when one went up, the other went down. All right, when one went down, the other went up. They moved in opposite directions. That creates a negative association. Now you can tell our relationships are making slopes, right? A positive association has a positive slope. A negative association has a negative slope. Okay. Now, just to see if you remember, if we're looking at golf score skill level, that one we just made, is that a function? Does anybody remember if that's a function? Functions are when we talked about inputs and outputs.
Oh, that. Yes. No. Oh, like, yes, it was like the difference between the output and the input.
All right, so with a function, okay, and this has nothing to do with this lesson. I'm just kind of reviewing something while we're on topic. In a function, every input has one and only one output. Okay? So does that meet that criteria? Every input has only one output.
Sure. Wait, like that graph or like?
Yeah, this graph right here. Does every input have only one output?
No.
No. Right here, for example, there's my input. I have 1, 2 outputs for the same input. So that would not be a function. Again, that's not part of this lesson. It's just good review.
Now I remember. Okay, I see what you're talking about now. We had like the two little egg things and like the line.
All right. Now, last type. Oh, I'm going to have to do it all tiny over here. Okay. The last type of association is no association.
No.
Okay, so no association. When it comes to no association, you could say something like,
Random dots everywhere.
we'll say hair color.
Oh.
And love of cake. All right. Your hair color, if we took the spectrum of hair color, all right, it has nothing to do with how much you like cake. All right? This blonde girl may really like cake, but this blonde girl doesn't. And then this black-headed girl likes it, but this one doesn't. And then as we plot all these points, there is no rhyme or reason to it, right? It's random. There's no association there. Okay? How tall you are and your high score on Halo. It has nothing to do with it. All right? No one's ever looked at a guy that was 7 foot tall and gone, man, I bet he's good at Halo. You know, it doesn't have anything to do with each other. Okay? So, no association means that there is no relationship between the two. But here's what I need you guys to see. Just because you look at it and think, there's no association. Okay, for example, let's talk about ice cream sales. Everybody loves ice cream, yeah. Ice cream sales and crime rate. Crime rate. So let's say the STAR test gives you a table with X and Y, and it's got all the different numbers in here. And it's like, what kind of association do you see with ice cream and crime rate? And they want you to plot the points and then answer the question. Most of you are going to go, I'm not plotting those points, that's lazy. And what do you think the association is between ice cream and crime rate?
None.
None. Most of you would say none. If you were to graph, and this is a true life fact, if you were to graph the various points on a scatter plot between the relationship between ice cream sales and crime rate, it would look something like this.
What? Really? Because everybody loves ice cream, and there is a lot of people getting arrested and stuff.
All right, so this is an actual relationship between ice cream sales and crime rate. And yes, when we're not selling a whole lot of ice cream, the crime rates are pretty low. And when we're selling a whole bunch of ice cream, crime rates tend to be very high. And that's a real life fact. But the logical side of us tells us that there is no relationship between ice cream and crime. There is no association there. But on a graph, we can see that there is a positive association. And here's why. When do ice cream sales go up? All right, and why? Because it's hot outside. It gets a little warm outside. And when it's warm outside, it's a little bit easier to stay outside and steal cars, isn't it? Okay? During heat waves, crime rates go up. All right, that's just a fact. When it's really cold outside, people don't go outside that often to break the law. So, heat waves create more crime, and they also sell more ice cream. So, really, the associations are with the heat, not with each other. But when we graph them, they still create a correlation. This is called a false correlation. Okay? But on a STAR test, if they were to give us this, it would be a positive association. That's what we would have to write down. And you would see it when you graph the points that they give you. Okay? But if you get lazy and don't graph those points, you're going to miss what would be positive associations. Okay? All right. So, just to make sure that we review everything here, we've got positive associations. That's where when one variable goes up, the other goes up. All right. Negative correlations, that means when one goes down, the other one goes up. They move in opposite directions. And then we have no correlation, which means they have nothing to do with each other. All right. But in order to really be able to see those things, we need to make sure that we actually graph these points. Okay, now, most of the time, and I will say this, STAR test will have scatter plots that are already plotted for you. And all you got to do is say, well, those are going up. Okay? And then all you have to do at that point is label positive, negative, or none. Okay? But they also like to give us things like this, where they say, okay, this is our study time, and this is our test grades. Now, if we were to look, I'm actually going to use the graph from page 395. Okay, if we have, it says 0.5, 1, 1, 1.5, 1.5, 2, 3, and 4. Continue that. Okay, 75, 80, 80, 85, 85, 95, 90, 100, and 90. Okay. Is this a function?
No.
Why would it not be a function? For which one? 1.5 and 1. Both of those have the same output, or same input with different outputs. Good. All right, let me take the time to draw this graph. Most of y'all should have it in front of you on your test, or your book, not test. All right. Okay, so as we plot these, we've got 0 and 75, 0.5 and 80, 1 and 80. Does everybody see how we're graphing these? All right, taking it straight from the table that they gave us. 2 and 90, 3 and 100, and then 4 and 4 and 90. Okay, so what type of association do we have here? Please answer where it's not in the form of a question. Positive, yes. It creates that positive slope look. So yes, this would be a positive association. Do we have any outliers?
Yes.
Where?
Kind of right there, that 4.
4 and 90 doesn't really lie with the rest of the points, and so yeah, that would be an outlier. Anything else?
What about 100?
That 3 and the 100 right there. It's just kind of like.
Okay.
Going here.
All right, so a lot of people want to label that as an outlier, but
Wait,
if
it's technically in the function.
if we were to create that line of the association,
Oh, so
it's right there on it, isn't it?
So that
so
1.5 guy.
Yeah, I could argue that right there is an outlier, but it's really not that bad, right? It's pretty close to the line that the relationship makes. We could make the argument that it's an outlier, but it's definitely not as clear as that one. That one's definitely not anywhere near. All right? But yeah, that 3, where they made the 100, it looks like it's apart from everything, but really it's just farther away, but it's still going in the same direction as everything else. Okay, so we need to be able to see that. All right, and tomorrow we'll talk about trend lines, where we draw that line and get an idea of where things should be falling. Okay, now, one thing that can happen, all right, is they could graph some points, and it may look like, well, all right, so we have all these points. We might have all these points, and I'm trying to create the graph that's on the next page if you want to look at it in your book. All right, and we might have something like that. Now, you could argue this is a positive association because they kind of are going up, but these are what we call clusters, okay? In a cluster, the set of data groups really closely around a certain point, okay? We saw already where it kind of centers itself around a line, but we could also say that we have a cluster here and a cluster here, and they're all kind of centered around like this point right there, and we could figure out what the point is to that cluster, or, you know, the center of that cluster is right there. Okay, so they can kind of, rather than just be along a line, they could center around a cluster itself, around a certain point. And you could come up with ideas about, like, well, whenever we are less than this number, we are clustered around that point. All right, or for more than that number, then we'll be around this point, something like that. All right, but we should still be able to, when dealing with clusters, identify an outlier, and that would be this point right there, right? It's sitting there all by itself, not near either one of the clusters. Okay? And so, if you have a problem that uses a cluster, don't let it throw you off. Okay? It's still the same idea. Okay? Now, in your book, go to page, we're going to be on page 397 now. Before you turn there, all right, reading level and height. What kind of association would that be? Reading level and how tall you are. None. Okay. Go to page 397. I'm going to pause the video and give you guys time to look at it. Okay, so now we have, this was our reading level. Okay, and this was the height. Now that we see the graph, Okay, we can definitely tell that what type of association is this?
None.
It's a positive. It's very clearly a positive association. Now, most of you said none at the beginning, and that's why I was trying to make a point of you can't just assume. We need to make sure that we see the graph. We graph the points if they're not already given to us. Now, in this particular problem, the points were already given to us, so it's pretty easy to see that, yes, there is a positive association. All right. As your height increases, so does your reading level. As your height goes down, so does your reading level.
Is it because you grow?
All right. And so the next thing they want us to do is describe why. What would be the reason? All right. And you just said it. As you get older, you get taller. And for most of us, as we get older, we become better readers as well. Okay? So most high school seniors can read better than second graders. All right? So as we increase in age, we increase in height. All right? And as we increase in height, our reading level tends to go up as well. So, again, this is an example of a false correlation. Really, height is associated with your age, and your reading level, it tends to be associated with your age. And so they're not really connected to each other, but they are in a weird way. So
Because like if you get older, you get taller.
exactly. So there is an association. Now there's also an outlier right there. Okay, I think on y'all's it's at like 6:45. Okay, that might be somebody who maybe they're just short in general. Maybe they're a high school senior that is only,
My height.
you know, 45 inches tall. Is super small. All right. So, but anyway, or maybe that's like a third grader that's just stupidly good at reading. Okay, so there's different outliers that could occur. Now, one of the things that comes up is you see this little symbol here. Okay. What is the number at that point right there?
0.
0. The next number we have is 40. Okay? What that tells me is that at 10, 20, 30, there were no points. So why waste all that graph space graphing 10, 20, 30? That all went in here. That's all your 10, 20, 30 stuff that had no points on it. So they make that little squiggle so they can skip that part of the graph. All right? And start right off where we start having points. All right? Sound good? All right. Guys, that is our intro into scatterplots. Again, tomorrow we'll look at trend lines and making predictions with scatterplots. But the main thing we need to know is associations, which we just covered. So, awesome.